Brother Nan, look at the skin on my arm.
What's the difference? It doesn't seem to be any different.
That's right, I 3D printed my skin.
3D printed skin? I thought you were joking. But I didn't expect you to be serious.
You don't understand this. This was developed by a team of experts from the People's Liberation Army General Hospital. International first, 3D bioprinted artificial skin with sweat gland function. Hello everyone, here is the Super Evolution Guide. The topic of this issue is 3D printing. New technologies are doomed to come with new problems, from computers to artificial intelligence. Can't escape its fate. 3D printing technology is a disruptive technology, or is it a flash-in-the-pan gimmick? Before answering this question, let's first understand what 3D printing technology really looks like. 3D printing technology is also known as additive manufacturing technology. It's a discrete material, based on digital model files, by adding up layer by layer, to create objects of arbitrarily complex shapes. Is it kind of arcane? Don't worry, let's focus first. Accumulate layer by layer, 3D printing technology, compared to traditional material removal techniques. The most obvious difference is, it is a bottom-up material accumulation manufacturing process. If it's still hard to understand, think of 3D printing as an inkjet printer. It's just that the inks used in 3D printing are not pigments. It's made of plastic, twigs, metal, and so forth.
Didn't I understand earlier?
The specific molding process is, you start with computer modeling software, or scan existing objects. The three-dimensional model to be built, partition into layer-by-layer sections and slices. Letter and guide the printer. Layer-by-layer printing with printing materials. Layer-by-layer addition of three-dimensional parts. So 3D printing doesn't require a mold. No knives. The only core device is the 3D printer. By high-precision mechanical systems, numerical control system, the injection system and the forming environment are composed of subsystems. Level 4 mechanical control and computer technology. Complex mechatronic system integrated with others.
Sounds so advanced. It must be very bumpy to develop.
No, not only not bumpy, it even went well. 3D printing technology, dating back to the late 1970s. By the early 1980s, at that time, Alan Haben of 3 Meters Corporation in the United States, Hideo Kodama from Japan, Charles of UV Leather, Hull and Yoji Maruko of Japan. The concept of 3D printing was independently proposed one after another. Now, 1986, Charles Hull pioneered light curing. This is a milestone in the development of 3D printing technology. Same year, he founded the world's first 3D printing device, 3D Systems Company. In 1988, the world's first 3D printer was invented. So, 1989, Chia Decherd invents selective laser sintering. The principle is to use high-intensity lasers, sintering the material powder until formed. 3D printing itself does not have many technical difficulties. More of a difference in thinking. It feels like 100 flowers are blooming in the early days. Until 1993, I'm a professor at MIT. Nusage invents a new 3D printing technology. That is powder injection molding technology. So far, 3D printing is like an inkjet printer. The advantage is that the production is fast and the price is low. Then SCO, previous and receives license from MIT. Utilize this technology to officially start production of 3D printers. See here, maybe someone is already questioning. No technical precipitation. Why replace traditional manufacturing? It doesn't feel valuable. It seems that I can do it too. It seems that 3D printing is a pseudo gimmick cutting leaks. First question first, can 3D printing replace traditional manufacturing? No. In terms of material selection, traditional manufacturing can use metals, almost all materials, such as wood, and 3D printing. The materials are mainly plastic resins and metal powders. Some specialized materials, such as ceramics, are still severely limited. This time with 3D printing, it is not a substitute for traditional manufacturing. They complement each other. 3D printing on complex structures. Personalized demand scenario dominance. Traditional manufacturing dominates large-scale, high-precision production. And here's the thing, there is also the possibility of deep integration between the two. Make full use of the rapid prototyping features of 3D printing. The advantages of mass production with traditional manufacturing. You can use the former to shorten the mold production cycle.
Nice.
In addition, in the aerospace industry, there are also people who have first used 3D printing to create complex structure blanks, the ability to enhance surface accuracy through traditional machining. Here's the second question. Is 3D printing a fleeting pseudo-concept? No, definitely not. With the process of economic globalization and knowledge is accelerating. Manufacturing, discrete from the simple industrial age. Traditional manufacturing, green in the era of globalization. The transformation of intelligent advanced manufacturing. 3D printing technology, as an important symbol of the third industrial revolution. It has the potential to fundamentally transform global supply chains, revolutionizing the way global manufacturing is produced. Have a profound impact.